concept. You just solve it in a different way. So first, a graphical approach. All this stuff, blah, 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 if it helps, use it. Okay? We're going to put the sucker in right there. Again, if you're leading off with a minus, you can't use the subtract button. You have to use this one down here. Okay? Otherwise, it'll just say error. So minus 4, that's just an approximation. What number should it be? What's the acceleration due to gravity on the surface of the Earth approximately as a number, Brenna? 9.8. What's 1/2 of 9.8? 4.9. They're rounding it to 4. That's okay. All right, whatever. T. Do I have a T in my calculator? I do, but why bother? Okay, use x. X squared plus 48. I'm going to let t be x. I don't care. Your calculator doesn't care what variable it is, right? Let it be q. All right? There's my standard window. And what do I see? Not a heck of a lot. I got to adjust my window. Okay? 48. Does that look like a kind of big number? Yeah. All right, so minus 10 to 10, well, let's leave that for now. I think I got to go quite a bit higher. So let's go 50. So let's cover that 48. Oh, see a little bit more. You think I got to go higher? Does that look like the, see that? Does that look like the edge of a parabola? Does this thing open up or open down? It's kind of nice to know what we're looking for. It opens down, right? It goes like this. Okay, it looks like an umbrella because it's negative. So does that look like the left-hand side? All right. I went to 50. That didn't, I saw a little bit more. You know what? What do you want to try next? 100 seems reasonable. Ah, see a little bit. Oh, and then we saw just a little bit coming down. See that over here? Okay. Let's go back and think about this question a sec. I didn't even read it, did I? The height h in meters above the ground of a projectile, here it is. Okay? At any time t in seconds after the launch. Okay, what does that mean after the launch? Above the ground. Okay, what I'm trying to say is, do we want any negatives? Above the ground. Like, this is the ground, right? Physically, that's what this thing's going to look like. Do I want negatives down here? Not really. Time. I know when we blast off a rocket, we go t minus 10, t minus 9. But for this problem, after the launch, do I want negative seconds here? Not really. I just want the first quadrant. I just want the positive quadrant. Okay? And it looks like that's where it is. So let's get rid of this. Okay? For the negative x, make that negative 1. And the reason is if I make it 0, then I'm not really going to see my axis. Okay? I don't want x is time here, right? It's not x, it's t. It's time. I don't want negative time. Doesn't make any sense. As soon as this thing's fired, this projectile, either it's launched, thrown, blown up, chucked, whatever, that's when I hit the stopwatch. Okay? So I don't want negative time. Why? It doesn't really go into the ground, does it? Okay? So I don't really want negative for y either. So let's just put my first quadrant there. Okay? Now I still got to get y quite a bit higher. Okay, that was 100. Let's go 200. Okay, now it's starting to look like a parabola, right? I want to be able to see where it leaves. That's here. And what did that eraser do? It hit the ground. Can I see where this thing hits the ground? No. So what do I got to do? X only goes to 10. I want to go a little bit further. So let's try 15. Okay? That's the pertinent part of this parabola, okay? The important points. That's it. Physically, that's what it looks like. If you stood there and looked at my eraser, that's pretty much what it looked like, okay? This, again, is time. That's t. This is height. Okay, that's what the question says. And if you were standing on the side watching this thing, or me throw my eraser, that's pretty much the path it's going to make, okay? This is time 0. As soon as I threw it, someone hit the stopwatch, and then 1, 2, 3, 4, 5, sometime later, it hit the ground, okay? Doesn't go into the ground, doesn't make any sense to have negative times, all right? Doesn't make sense to have negative time, but again, that's why I chose -1, so I can see that axis right there, okay? That's what you want to see. Now, we've got some questions. Answer the following. Sketch the relevant part of the parabola on the grid. Here it is. Does it look like this is right at the origin, this line?
No.
It looks like it's a little bit above it, doesn't it? Like, I don't know, about there. And then it goes up. And then it comes down. Okay? That's what it looks like. When something is thrown, a football, golf ball, those little dimples actually make it do some strange things in the air. But, I mean, if it didn't have those aerodynamic effects, it would make a parabola shape. Okay? A rocket, once it stops powering, it's going to come back down to Earth. That's the shape it makes. Okay? That's it. Now, find the height of the projectile 3 seconds after the launch. How many seconds was this till it hit the ground? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like about 12. Okay, approximately. This is time 0. I want to know like time 3. What is the height? Time 3. How would I do that algebraically? Well, if you know t is 3, could I plug it in this formula and solve it? Sure, right? H of not t, but h of 3, this is a function on time, right? This is the height based on some time. Is -4, 3 squared, plus 48 times 3 plus 3. Okay, I could do that and find out, but is there a way to do that on my calculator? Hit trace button. And you see every point there, if you move this cursor back and forth, it tells you, okay, what x is, what y is, right? At 4.27 seconds, this thing happens to be 135.1 meters in the air. What if I want a specific point? You could kind of trace and go over to 3, or put 3 in the calculator. Hit enter. That's how high it is at 3 seconds. Okay? Now if I solve this, I'm going to get the same thing. Okay? And if I ask you to solve it, well, you know, if you're using your calculator, you can use it to check. But if you don't do this, well, like I said, I can't really give you the mark, right? That's 111 meters. Okay? Maximum height. Graphically, where is that? Is there a word for that? Yeah. That's the maximum, right? That is the vertex. Remember where we started all this vertex stuff? It's either a maximum or it's a minimum. That's the definition of the vertex. So graphically, if we got it, okay, first of all, I can put this on my graph. If that's 3, that's 111 meters high. What's the vertex? How high is that? I could do that again, kind of trace, right? But is that just, that might just be approximate. I need an exact answer. This calculator knows how to do this. You know how you define zeros? It's the same button. Second function, calc. You see the word maximum there? That's how to find the vertex. Go down to maximum, hit enter. You got to go left of the maximum, that's fine. Then you got to go right of it. Notice the height for y gets higher and higher and higher, then it starts getting lower and lower and lower. Make sure you're right of the maximum. Hit enter. Does the maximum look like it's in between those two arrows? Yes. Yes, please. 5.99999. Okay, common sense. Are we going to round this, Reese? Yeah. The maximum occurs at a time of 6 seconds. And how high does this thing get? 147 meters. Okay? 6 seconds, it's 147 meters. All it says is, what's the maximum height? 147. I have units. Don't forget to put them meters high. Okay? Do we see how we're going to find this algebraically? Converting it into vertex form. Okay, I'll be doing that in about 5 minutes. How many seconds after the launch is the maximum height reached? I already answered that, didn't I? Because I put it on my graph. 6 seconds, right there. Okay? There it is. At 6 seconds, it's at the maximum height. Okay? And don't assume, like, I know parabolas are symmetrical, but again, remember, when it asks you when does it hit the ground, don't just double this. Well, that's halfway. It's got to be 12, because remember I said this doesn't quite start at 0, 0, does it? Okay, it's going to be close to 12, but we're not quite sure. So it's nice to be thinking symmetry. If I know one 0, I know the other 0, but careful, that's not a 0. Okay? What was the height, speaking of which, at launch? We got a word for this. We would call it a y-intercept. Okay? But what is y? There is no x and y here. It's t and h. So it's not y. What do we call this? Yeah. That's my h-intercept, right? That's when the time is 0. Is that pretty easy to figure out algebraically? If I put 0 here and 0 here, what's the height? Yeah, it's 3. Don't even bother bringing out your calculator, okay? That's that little distance right there, okay? Think about it. Here's my eraser. I already threw it. Am I going to get right down on the ground and throw it? Or is it going to be some height off the ground when I let it go? In this case, it's 3 meters off the ground. That's how high the launch pad is, okay? So again, it's not a 0. It's not an intercept here, all right, for x, okay? It's some height off the ground when it goes. Does that make sense? How high off the ground? 3 meters. Okay, so h of time 0 is 0 plus 0 plus 3. That's 3 meters off the ground. Could we do this on here too? Sure. Okay, x0, there it is. At time 0, y is 3. Okay, but like I said, why bother? Look at the equation. That should be pretty easy. Okay? Determine when the projectile hit the ground to the nearest 10th of a second. What's the name for that? Dannon? The x-intercept. Yeah, that's where it hits the ground. That's a 0, right? What's another word for a 0? a root. What's another word for that? You already said it. X-intercept. Okay? That's important. This doesn't say anything like that, but that's the concept for this question. When does it hit the ground? That's an intercept. That's a 0. Do we know how to find a 0? Sure. Second function, trace. And we expect it to be about what? About 12 seconds, but that's just approximate, right? Okay, so where's this guy? He's way over there. I gotta bring him way over to the other one. Gonna get carpal tunnel before I'm done this. That's okay, I already got it. I do, you know. Okay, left, enter, right, and now because this, I only have the first quadrant, it's hard to see. It's gone. How do I know when I'm right of it? Yeah, when y is negative. It said negative 2. Let's just make it negative 10 just to make sure. And again, if you lost your cursor, you don't know where it is, that tells you where it is. It's minus 10. It's either here or it's there. I know that for sure, right? Okay. So that's definitely right of it. It's below the y-axis. Sorry, the x-axis. What is that 0? To the nearest tenth. It's not 12. 12.1 seconds. That's when it hits the ground. Okay? It's not just a 0 now. This thing has meaning. Okay? 12.1, I have units. It's seconds. Okay? So let's fix that. 12.1 seconds. All right. My foundations kids are pretty good with this because they did it for like 5 days. All right. They all got the marks on the test. All 11 of them. What's the domain of this? It doesn't say it. Does this parabola have arrowheads on it? Again, we have to think about the context of this question. Does this thing go into the ground forever and ever and ever? No, it doesn't. So that doesn't make any sense. My domain goes from 0 to 12.1. That's it. Okay? So for this question, it's not all real. It's less than or equal to 12.1, greater than or equal to 0. Same thing for range. Like it doesn't ask it here, guys, but it might on the test. Range, it's every value less than or equal to 147, but do I have a lower limit on my range? Yeah, it doesn't go into the ground. It goes lower than 3 because it does hit the ground at 0, right? So it's everything from 0 to 147. That's the range. Okay? So on a test, like we're going to have to complete the square. We're going to have to do some algebra, but if you got a graphing calculator, hey, you can check it, right? You can check every one of these questions. Flip on over to page, what's this? 355. Okay, like I said, that's the same question. Now pretend you don't have a graphing calculator. And this is going to be practice for tomorrow because we're going to, how do I find out where the vertex is? What's the process called? Completing the square. Changing this thing from general form into standard form or vertex form. Okay? So, and there it says it right there. Same question. This is a projectile, okay? It's Mr. Watson's eraser. He's going to chuck it across the room, okay? I must throw it pretty hard because you know it's in the air for 12.1 seconds, okay? There it is. That's the equation that makes that shape. And, you know, if this was a video game, in the code, if this was actually that object that made that projectile, that shape, that would have to be in there. Okay, that's what tells the game what shape to make this thing, right? I think those kids in that DigiPen are doing this kind of stuff, right? I saw John the other day. He said, man, we're using a lot of math. Okay, all they do all day long, one course is play games, writing code. It's a lot of math. Sounds like fun, though. Okay? All right, so what do? A is not 1. What is step 1? Factor it out of the first two things. Okay, so take a -4 out of that, and out of this one, the sign's got to be positive. Okay? Next, pretend the -4 isn't there. Pretend this is 1t squared minus 12t. What do I got to do now? What's half of 12? 6. Square it, add it, and subtract it. And I still have plus 3. Okay, all of that's in the brackets. Okay? Is this the same thing as this, Jake? Yeah, because I just added 0, right? Plus 36 minus 6. I didn't change it. Is this the same as this? It's a good idea to double check before you go any further. If you made a mistake here, guys, if you got a positive instead of a negative, you're going to do 5 minutes of work for nothing. It's all going to be wrong. Okay? Double check it. -4t squared, check. -4 times -12t is positive 48t, check. All right? Now what do I want? What did I do here? Out of the first 3 terms, I want to complete the square. I want to make this, that's a perfect square trinomial. I want to write it as a binomial. So I'm going to go and forget about that -4. And these 3, I'm going to go t minus 6 squared. Okay? Is that the same as the first 3? And if you got to write it out and check it, then do that, okay? Now I still have this guy. I want to collect him with this 3, but before I can collect him, it has to be multiplied by that -4, right? What is 36 times 4? 144. That's positive. Negative times a negative. Okay, and I still have my plus 3. So in completed squared form or vertex form, hey, does that 147 look familiar? What's the vertex of this parabola? 6 and 147. Okay? Ignore the minus sign here. I know it says -6. This is the number, right? When t is 6, this becomes 0, and y is 147. That's the maximum. This tells you the vertex, right? This is PQ, right? Yeah, that's in PQ form. If it's a minus there, where does it say that? Right here. All right, remember that's vertex positive PQ. Okay? That's in the same form. If that was plus, then P would be a negative, right? This is positive. And again, we're talking, this is time. Negative doesn't make any sense. Okay? So, I've already answered which. There it is. Okay? Hey, there it is. I've already answered it. Just because I know that's in vertex form. But don't be lazy like me. Put units. Okay? Find the height of the projectile 3 seconds after the launch. Again, I already wrote this out. If I do that, I will get, what was the answer? Okay, I already did it. It was 111. Okay, but plug that in your calculator, and you'll get 111. You can do it in one line on this thing if you're clever. Okay, at launch, it's worth emphasizing what's the understanding here. This is called a what? Here it is graphically. That's it right there. I want to know, what is this height? What is this thing called? What is the h-intercept? Okay? When time is 0, what is the height? Okay? And that's easy graphically to figure it out, because that is just, well, they didn't give me much space here, but let's write it out. h of 0 is minus 4 times 0 squared minus 40 plus 48 times 0 plus 3, and that of course is 3 seconds. Whoop. Meters. H. Okay. 3 meters. When someone hit the stopwatch, time was 0, it was already 3 meters in the air. Okay? Then it got shot up. Okay? Does that make sense? When the projectile hits the ground, how long was it in the air? That's the same question. Okay? How long was this in the air? Until it hits the ground. What do we call this? That's an x-intercept, but here x is t. Okay? So, algebraically, when is this thing equal to 0? Okay? When 0 is minus 4, here it is here, t minus 6 squared plus 147. That's what I got to solve. Okay? So minus 47 to both sides. 147, did I say 47? Okay. Minus 147 is minus 4 t minus 6 squared. What do I want to do next, Jake? Sorry? Yeah. Okay, get rid of that minus 4. And it says nearest tenth. So again, sometimes it'll say exact answer, other times it'll say tenth. I'm already going to use decimals. So let's make it a decimal already. Okay? What's 147 divided by 7? Oh, I gotta get out of there. 36.75. Okay, 36.75 is t minus 6 squared. Now I expand all that out, right, Reese? And then get stuck? Or do I do something else? Take the square root to get rid of it, right? Square root of that, square root of that. So t minus 6 is, but what do I got to do? Yeah, plus or minus that, which is, what's the square root of that? 6.062. I need it in tenths, but I'm not going to square it or take the square root of this again, right? I'm not thinking out loud. All I'm going to do is add 6 to this, right? So I can round this to tenths now. So that's 6.06 plus or minus. Okay, so add 6, add 6. So t is plus 6.06 plus 6, or minus 6.06 plus 6. And then we go back and think, what am I getting asked here? When does this hit the ground? What's minus 6.06 plus 6? What's the sign? Does this have any meaning? Negative time. So you got to reject that. Okay? When does this hit the ground? 12.06, but to the tenths, 12.1 seconds. And that's what we got before, wasn't it? Okay? So we got to reject negative time. I get 2 answers here, but like we did before, one of them makes sense and one of them doesn't. Okay? Compare. Same. Okay, so this is how we got to do these algebraically, but again, if you got a graphing calculator, you can check them. Okay? So number 1, 349. Whoop, and 358. Number 1 and 5. Again, do these vertex, completing the square algebraically, and then check with a graphing calculator, okay, if you got one. And quiz tomorrow.